A previous video started with the basics of how to write a procedure using assembly language. This one's going to go into more detail and show you how to use things like parameters on the stack and local variables, which coincidentally will also be on the stack. We've been passing parameters using registers, and now we're going to start passing them on the stack. And you might wonder, well, why should I even bother to do that? Here's a couple of reasons. Number one, you might just run out of registers. If you've got a bunch of parameters, realize the registers in the CPU are pretty limited. I don't want to run out of them. Another reason is almost all high-level languages pass parameters on the stack. And if we're going to use some of those high-level languages as part of our programs, then we're going to need to match what's called calling conventions. And you've already been using a calling convention. It's called standard call. And you've been putting that designation when you declare what model we're using for the program, right up at the top of the program. To understand how all this works, we've got to take a look at stack frames. Now you might be wondering what a stack frame is. It's an area on the stack that's created every time a procedure or function is called. You got to keep in mind, it's built only when a procedure or function is called. Let's take a look at how that happens. And let me remind you that the stack is building downward in RAM. First, the parameters get pushed on the stack. Then when the procedure gets called, the return address of the calling procedure gets pushed on the stack. The next thing that happens, once you get into the procedure, is the EBP register gets pushed. And at that point, wherever the stack pointer is pointing, that's copied into the EBP register, and the EBP register points to the same spot on the stack. Wherever the EBP register is pointing, it's going to stay there throughout the procedure. It's not going to change. It's acting as a point of reference, a base if you will, and that's really what the B in that register stands for. If you take a look on the right, you'll notice that I can reference the parameters relative to where the EBP register is pointing. I can also reference where the local variables are relative to the EBP pointer. But that gets more complex. Now the stack pointer itself is going to continue to move downward if we've got more things to put on the stack. For instance, if this is going to use local variables, then they need space on the stack too. Again, that's below where the EBP register is pointing. And finally below that, any registers that you're going to use in the procedure, you need to save them by pushing them on the stack. Keep in mind that this has always been going on in high-level languages too. The compiler's just been writing the code for you. Let's take a second to review how we pass a parameter by value in a high-level language. We'd probably do it this way and send an integer x and a character ch to a function. But are we really sending x and ch to the function? No, we're sending copies of x and ch. The originals aren't changed at all by a function. That is, when we send parameters by value. To mimic this in assembly, we'd have to do it this way. Since x is an integer, I can copy it directly into a 32-bit register. ch, on the other hand, is only a byte, so I copy it into an 8-bit register and then extend it to a larger one. Then I push the parameters in reverse order, because that's what high-level languages do, and then finally I get to call the function. To pass a parameter by reference, on the other hand, this is how we do it in high level. Pay attention that we're saying that it's a reference parameter, meaning that what I'm sending is the address of that parameter, not a copy. I'm giving that function complete access to my original value. This is pretty easy to accomplish in assembly. We just push the offset of the value, then call the function. So now we've got our parameters on the stack. How do I get to them? Here's the first version. Let's assume the stack looks like this, with one of our parameters having a value of 45 and the other having a value of 100. Below that is the return address that we'll go back to when this procedure ends. Here's my code. I've got to reference those parameters by where they are in the stack relative to the EBP register. By the way, pretty much the only thing you ought to ever use the EBP register for is to use it with a stack like we're doing right here. Anyway, the code's saying go 12 bytes higher in RAM than EBP is pointing to. That sends me here, and I can access the 45 that's stored at that location. The next line of code says go 8 bytes above where the EBP register is pointing, and I can get the 100. Now this type of addressing is called explicit stack parameters or explicit stack addressing because you're explicitly saying, I want to go this many bytes above where EBP is pointing. So let's say my procedure runs and I get all the way down to the end and I reach that return instruction. When that instruction executes, the return address is going to be popped off the stack. I'm putting a question mark there because we don't know what's going to be there then. And the stack pointer will move up to where the 100 is stored. That means when this procedure ends, I'm leaving 2 values on the stack that shouldn't be there. How do I fix it? The answer is, it depends. It depends on the calling convention that I'm using. If I'm using the C calling convention, then I don't worry about it, because the procedure that called this one has to take care of it. It's not my job, in other words, is this procedure. But if I've been using the standard call convention, like we've been using, then this procedure has to take care of the problem, and the way you do that is to first figure out how many bytes of extra stuff are on the stack. In this case, I've got 2 double words. That amounts to 8 bytes. And I indicate like this to tell the assembler, hey, add 8 bytes to where the stack pointer's pointing. And that'll fix things. So the textbook gives us this example of a procedure. Notice how many things are being pushed on the stack. EBP, ECX, EDX. The first 2 lines where EBP is being pushed and then where the stack pointer is being copied into EBP, those things happen automatically. You don't have to worry about that. But the other 2 registers, we've got to take care of. And when we get to the end of the procedure, we have to remember to pop those registers in reverse order. Now when EBP gets popped, that's automatic, just like when it was pushed. Then we get to the return statement. I'm leaving out anything to do with parameters, local variables. This is just if we're using registers inside that procedure. What a nightmare. Instead of doing it that way, let's take a look at version 2. Here I'm going to give you an example that will really simplify our lives. After the proc directive, put your uses directive. Here, since I'm using the EBX and the ECX registers in the procedure, I put them in that uses directive. Put a comma after that. Below that, put any parameters that you're going to pull off the stack. Notice how I can give them names now. I don't have to access them relative to the EBP register. I can also tell what type of data they are. We really want to keep those double words. In this example, value 1 is the first parameter, and value 2 is the second. Remember, we pushed them in reverse order. You separate those parameters by commas. After the last one, though, don't put a comma. Below that, we can declare our local variables. Here I'm calling a local variable total1, and I'm making it a double word. Now, if you want to, you can read in the text about handling local variables relative to the EBP pointer, but I'm telling you, that when you start combining local variables with parameters, with registers that we're using inside of a procedure, that's a fast track to going crazy. If you'll use this form right here, it's going to make it a lot easier for all of us. This will get you started on writing procedures with parameters on the stack and with local variables. That's enough to make you really dangerous. If you got questions though, please get in touch with me. Thank you for watching this.